Alright, what's up guys? In this video we're going to pick up some calculus here and we're going to be talking about derivatives of integrals. So we're asked to evaluate the derivative with respect to x for the integral of x to the 14th dx. So remember, for derivatives of integrals, they are very easy. And I'm going to work through the whole process to kind of prove it to you. So no worries on that. Now, we're just going to focus on indefinite integrals in this case, but I will do a separate video for derivatives of integrals with definite integral, where basically all you have to do is use part one of the fundamental theorem of calculus. So I'll do a separate video for that one. So for derivatives of integrals, basically all you really do in this particular case for the indefinite integral is you'll go ahead and take your integral and evaluate it, and then you'll take the derivative of the result. And basically what you should end up getting once you take the derivative of the result is exactly what's in your integral. So remember, if I take the derivative with respect to x and I have the indefinite integral of some function f of x with respect to x, well, when I integrate it and then take the derivative of the result, I should just get what is in my integral. Okay, so let me just kind of prove to you, even though we know that the answer is going to be x to the 14th, let me just prove to you why the answer is going to be x to the 14th. So let me just quickly remind you of some very important rules here that you guys probably already know, but we're going to review them anyway. So let's talk about the power rule for derivatives, okay? So if I want to take the derivative with respect to x of, let's say, x raised to the n, well, that's just going to be n times x raised to the n minus 1. Hopefully you remember that. That's your power rule for derivatives, and we know we have a power rule for integrals as well. Again, I'm just going over this because everybody might not know. And so remember that the power rule for integrals, if I have the integral of x raised to the n dx, well, that's just x raised to the n plus 1 all over n plus 1. A lot of students forget about the restriction on this formula. Remember, n cannot equal -1 because we'll get division by 0. So keep in mind the restriction on the formula there. So let's just go through and just do it and see how we get our answer. So let's just go ahead and take our antiderivative. Let's begin with x raised to the 14th dx. Well, the antiderivative for that is x raised to the 15th over 15. Don't forget to add the constant of integration. Now what we'll do is we'll differentiate with respect to x our result, which was x raised to the 15th over 15 plus c. When we differentiate this, we should get x to the 14th back out. If you don't get x to the 14th back out, check your integration and check your differentiation, because that's more likely where the mistake is going to lie. So let's break this up a little bit. So this would be the derivative with respect to x for x to the 15th over 15 plus the derivative with respect to x of c. C is just a constant, so we already know that's 0. We differentiate a constant, we get 0. So let's differentiate with respect to x raised to the 15 over 15. Well, pull out a constant. So pull out a 1 over 15 and then just differentiate with respect to x raised to the 15th using the power rule for derivatives. So we'll have 1 over 15 multiplied by 15x to the n minus 1, which would be 14. So we'll have 1 over 15 times 15x to the 14th. The 15's cancel out. 1 times x to the 14th is x to the 14th. So when we differentiate, we get x to the 14th, which is the exact same thing that was in the integral. So that's how you do derivatives of integrals. So your final answer here, obviously we already know what it is, but I'm write it down anyway. We wanted the derivative with respect to x for the integral of x to the 14th dx, and again, it's just x to the 14th. That's your answer. Okay. So let me know if you got any questions about it. Again, pretty straightforward video there. But again, I'll post one where we do it with definite integrals, which again is easy as well. But I just wanted to do indefinite integrals in this video. All right. I'll see you guys next time.